So today we're going to look at balancing ionic compounds and how to make up their formulas. On this first slide you can just see there's a few different examples of ionic compound. In particular, note in the centre one, in this image here, it shows you the sharing of an electron between sodium and chloride. And this is what you need to keep in mind as we go through this whole process, is that you still have to be able to explain why these formulas are what they are. So for example, in this one here, sodium is a metal, it's a positive ion, and it has one electron in the outer shell. Chloride over here is a non-metal, it is a negative ion, and it has, it's kind of missing one of those electrons in the outer valence shell. The ions or the atoms are not very happy the way that they are, and so sodium ends up donating its one electron in the outer valence shell over to chloride, which accepts it, and you can see down in this image here that we have a much more stable relationship where sodium and chloride are going to sort of share that electron between them. Okay, so now we're going to go through how you actually look at these ionic compounds and balance together. Okay, so to start, you need to have a metal ion and also a non-metal ion in order to make an ionic compound. And we know that the metal ions are found over on the left side of the periodic table, and the ones that we are most commonly going to be using are these sort of ones over here. So lithium, sodium, potassium, calcium, magnesium, those sorts of metal ions here. The non-metal ions are found on the right side of the periodic table, and some of the basic ones here that you can see will be the oxide ion. Remember that the non-metals change their names when they become ions, so instead of an oxygen ion it becomes oxide. Fluoride ion, sulfide, chloride, those are the main simple ions that we are using at the moment. We will eventually move on to polyatomic ions, so things like SO4 2-, which is sulfate. Okay. Alright, so let's pick a metal and a non-metal in order to make a compound out of. So let's start with the metal. Let's pick magnesium. So we're going to look at a compound between magnesium, which is a metal, it's a positively charged ion, and the other one we're going to look at the moment is chloride, which is a negative ion. We're going to do two examples, and the second one we'll look at also is from over the side, and so sodium over here is a metal ion, it's a positive ion, and over the other side we're going to pick a non-metal, so let's pick oxygen to do for that one. Okay, so the next screen we're going to look at how we actually remember what the charges are of these ions. Okay, so let's do our first example of magnesium chloride. So we have magnesium and chlorine. Oh, it's actually still chlorine because they're atoms at the moment, not ions. And so what you need to do is either go and look at your ion table, or you can actually go back to those dot and cross diagrams and see how many outer electrons there are in that outer shell, and therefore pick up the charge of them. So either using the tables or the dot and cross diagrams, we can see that magnesium is a 2+ ion, and so what that means is that it has 2 electrons in the outer valence shell, and it's not very stable like that, so it loses those 2 negative electrons, and therefore its overall charge becomes 2 positive. Chloride is a 1- ion. We don't actually have to write that 1 down. And chlorine has 1 electron missing in the outer valence shell, so it has 7 electrons instead of the full 8 in the outer valence shell. Not very stable, and so it prefers to gain 1 electron, and therefore it will have an overall 1 negative charge. The second example that we're going to do is sodium oxide, and so sodium, we can see either from the table, we can use the periodic table for this as well. Sodium has a 1+ charge, and oxygen has a 2- charge. Okay, so we're going to do these two different. Okay, so we're going to put the ions together and balance them. So the first thing that we're going to do is write down, we'll do magnesium first. So magnesium is 2+, And what this means is that it has the ability to give away 2 of the electrons. So because of that, I'm going to draw it in this special shape. And what it shows by having these 2 kind of indentations here is that it has given away 2 of its electrons. So it's almost like it's missing a couple of electrons there. And because it is 2+, it has 2 gaps that it has given away. Chloride is Cl-, and I'm going to draw it like this. And what that shows us is that chloride is a minus, so it's gained 1 electron, so it's almost gained something into its structure. But this is not balanced. So we have 2 gaps over here, and we've only filled in 1 of them with the chloride ion. And so what we have to do is we have to put another chloride ion in there, and that makes a really nice balanced compound. So you can see that both of these electrons have been shared nicely between the 2 ions. So if we're to write that formula down, we have 1 magnesium, and so we will write down Mg, and then over here we've got 2 chloride ions, and so we have to write down Cl and 2 down the bottom. So it's quite important that the 2 is placed down towards the bottom of that formula. When you're writing the charges on them, you'll notice that it goes up the top. So Mg2+, the 2+ is always at the top on the right side. Cl-, the minus is at the top on the right side. But the numbers, when you're balancing the formula, always go down towards the bottom. Okay, so that is MgCl2, which is magnesium chloride. Let's do the second example, which was the sodium oxide. We'll just clear this off. Okay, sodium Na+. Okay, and so this one is only able to basically give away one electron. And now we're going to do the oxygen. So O2-. This is actually gained 2 electrons. So we're going to draw oxide as having gained 2. Sodium has only lost 1. So it's not balanced at the moment. It is not an ionic compound. It's not balanced at the moment. So we draw another one on. Okay. And so now you can see that there are 2 sodiums to 1 oxide ion. So if we're to write the formula for this one down, I'll do it up the top. We have sodium, and we've got 2 of them, so we write it down the bottom. Oxygen, only 1 of them, and we don't actually have to write that 1 down. We can just leave it as O. So Na2O is sodium oxide. So this is how you actually end up explaining the formula. When you're asked a question to explain why the formula is Na2O, you explain that sodium has only a 1+ charge because it only has 1 electron in the outer valence shell, and so it gives away that 1 electron to oxygen. Oxygen has 6 electrons in the outer valence shell, and therefore it can accept 2 electrons. That's where this 2- comes from. But it is not balanced with just 1 sodium, and so you need 2 sodiums in a ratio to 1 oxide molecule, or 1 oxide ion, sorry. Okay, so explaining this formula comes from the simple ratio of there are 2 sodium ions for every oxide ion. Okay, I'm going to show you the swap and drop method, which is kind of like, it's a much simpler, it's kind of like the cheats method of being able to figure out how you make up these formulae, and it can be a much quicker way of doing things. However, it is not enough. It is not appropriate to use this method to explain why the formula is what it is. So that's what we were just talking about previously. So let's do this with both of the 2 examples that we've done already, and I'll demonstrate to you how we kind of figure it out. So magnesium chloride will go first. So Mg2+, oops, and Cl-. And so the swap and drop refers to the idea that you take this 2 charge number, so this 2, you swap it over to the other side, over to the chloride side, and drop it down to the bottom. This 1, because remember it is actually like a 1- charge, you take that over to the other side and drop it down. And so what you would end up with is Mg, and you've taken the 1 from here over down there. Remember, we don't have to write ones down, so it actually becomes like an invisible one that's sitting there. And then Cl, and what we've done is we've taken the 2 from here over to the other side and dropped it down. Now we do have to write that 2 down, so we will write MgCl2. So it's a much simpler way of doing things, a much quicker way of doing it, but it doesn't explain it to the full extent. Okay, so let's clear this one up and we'll do the next one. Okay, so the last one that we did was sodium oxide. Okay, so Na+, and remember it's kind of like a 1+, oxide O2-, and so what happens is that we're taking this 1 over to the other side, dropping it, so swap, swap, drop, and then we're taking this 2-, swapping it, and dropping it down to the bottom. So if we were to write this formula, you would write Na. This 2 has come over and dropped down. We do need to write the 2. So write a 2 like that. And then with the oxygen, what we've got is we've got a 1 that's gone over and dropped down. And because we don't have to write 1s down, that final formula would be Na2O. So that's the swap and drop method, the much simpler method, but once again it is not a full explanation as to how this formula is what it is or why it is what it is.